Welcome to a video on how to determine arc length in parametric form. So if we have the parametric equations x equals f of t and y equals g of t, and they don't cross each other on the closed interval from a to b, then the arc length is given by the definite integral from a to b of the square root of dx dt squared plus dy dt squared integrated with respects to t. And if we wanted to, we could rewrite dx dt as f prime of t, and we could rewrite dy dt as g prime of t. Now we have talked about arc length before in rectangular form, and we can take the same formula for arc length in rectangular form and derive this formula, but we won't take the time to do that in this video. Let's go ahead and take a look at our first example. We want to determine the arc length of the curve on the interval from 0 to 2 pi of x equals 2 cosine t and y equals 2 sine t. So the arc length would equal the definite integral from 0 to 2 pi of the square root of dx dt squared. Well, x is equal to 2 cosine t, so dx dt is negative 2 sine t. We'll square this, plus dy dt squared. Well, if y equals 2 sine t, then dy dt is 2 cosine t. So we'll have 2 cosine t squared. Let's go ahead and square these. We have the square root of 4 sine squared t plus 4 cosine squared t. Notice the radicand here does have a common factor of 4, so let's go ahead and factor that out. So we'll have 4 times the quantity sine squared t plus cosine squared t. This simplifies nicely because sine squared t plus cosine squared t is equal to 1. So this is the square root of 4 times 1, or the square root of 4, which is just equal to 2. So this becomes a definite integral from 0 to 2 pi of 2 with respects to t. So the antiderivative of 2 would be 2t. Now we'll go ahead and evaluate this. We have 2 times 2 pi minus 2 times 0. So this arc length is equal to 4 pi. Now this really shouldn't be a surprise. Remember, if we graph x equals 2 cosine t, y equals 2 sine t, that'll give us a circle with radius 2. Let's go ahead and take a look at that. Well, here's the circle, and we just determined the arc length from 0 to 2 pi was equal to 4 pi. Well, that would just be the circumference of this entire circle. And remember, the circumference formula is c equals 2 pi r. Well, our radius is 2, so we'd have 2 times pi times 2, which is 4 pi. So we really just used the arc length formula to find the circumference of the circle, which would have been much easier just to use the circumference formula. Let's go and take a look at another example. Now we want to determine the arc length on the closed interval from 0 to 2 of the curve defined by these parametric equations. So the arc length will equal the definite integral from 0 to 2 of the square root of dx dt squared. Well, dx dt will just be 2t, so we'll have 2t squared plus dy dt squared. Well, dy dt is going to be t squared, so we'll have t squared raised to the second. Let's go ahead and start to simplify the radicand. We'll have 4t squared plus t to the fourth. Now, just like the last problem, this radicand does factor. These two terms have a common factor of t squared. So we'll have t squared times the quantity of 4 plus t squared. Now this is going to simplify because the square root of t squared is equal to t. So our integrand is going to be t times the square root of 4 plus t squared. And let's go ahead and write the square root of 4 plus t squared as the quantity 4 plus t squared raised to the 1/2 power. Notice that 4 plus t squared has degree 2 and t has degree 1. So this tells us we can use the technique of u substitution to evaluate this integral. Meaning if we let u equal 4 plus t squared, then du is going to equal 2t dt. And notice we have a t dt in our integral, so we'll go ahead and divide by 2. We can replace t dt with 1/2 du, and we can replace 4 plus t squared with u. Let's go ahead and do that. Again, t dt is equal to 1/2 du, and 4 plus t squared is equal to u, so this is just u to the 1/2. We'll temporarily leave off the limits of integration, since now we're in terms of u, not in terms of t. So this will equal 1/2 times u to the 3/2 divided by 3/2, which is the same as multiplying by 2/3. So we'll have 1/3 4 plus t squared to the 3/2 power evaluated at the upper and lower limits of integration. So we'll first replace t with 2. So when t is 2, we'll have 4 plus 2 squared, that'll be 4 plus 4, 8 to the 3/2 power. And then when t is 0, we're going to have 4 to the 3/2 power. 4 to the 3/2 power would be the square root of 4, which is 2, raised to the 3rd power, so this is equal to 8. So we're going to have 8 to the 3/2 minus 8 all over 3. And we'll go ahead and convert this to a decimal. I've already done that. It's approximately 4.88. Now before we take a look at this graphically, let's go back up to our parametric equations. Let's go ahead and determine the 2 points on the rectangular coordinate plane when t is equal to 0 and t is equal to 2, because this arc length represents the distance between those 2 points. So when t is equal to 0, x would be 0 squared minus 1, or negative 1, and y would be equal to negative 2. When t is equal to 2, we'd have 2 squared minus 1 for x, that'll be 3. And for y, we'll have 2 cubed, that's 8 times 1/3, 8/3 minus 2. Well, 8/3 minus 2 is the same as 8/3 minus 6/3, so that'll be 2/3. So the distance between these 2 points on the curve would be approximately 4.87 units. Let's go and take a look at the graph. So when t is equal to 0, here's our point -1, -2. And when t is equal to 2, here's our point 3 2/3. So the distance along the curve from this point to this point would be the arc length, which we found to be approximately 4.88. Okay, I hope you found this video helpful. Thank you for watching.